Hi. All right. So we are on day 16 of the free CCNA for the Cisco. Okay. What we're doing with this is we're going to watch this. I think there's another part. I don't know if we'll watch the other part or not. We may or may not. We're definitely going to do some practice with some subnets, and we still need to go back and do day 15's packet tracer. So we got a lot on the plate today. I hope everything's going well. I hope you're having a wonderful day, a wonderful morning. I know that I'm a little late, but I'm not nearly as late as I was, what was it, yesterday or Monday. Yeah, we're gonna go ahead and we're gonna get cracking on this. There we go. I always have a monitor because I need to know if my volume is okay or not. Anyway, here we go.
Welcome to Jeremy's IT
If you have not
Lab.
already subscribed to Jeremy, you should.
If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. So, today's topic is another big one. Today's topic is VLANs. VLAN stands for Virtual LAN, Virtual Local Area Network. It's very important that you understand VLANs well for your CCNA exam, and certainly when working as a network engineer. So, feel free to ask any questions if you don't understand.
Yeah, because the last
Here are the topics we will cover in today's video. First, what is a LAN? We know it stands for Local Area Network, but I'll give you a more specific definition. To help understand LANs and VLANs, we will also look at broadcast domains. After looking at LANs and broadcast domains, I will introduce you to VLANs, virtual LANs. I will teach you the basics of VLANs and their purpose. Finally, we will look at the basics of VLAN configuration on Cisco switches. By the way, this won't be the only video on VLANs. The next video, day 17, will also be on VLANs. So this video will just cover the...
So from what I understand what VLANs are, they're groupings of LAN connections that are virtual. So that way they're basically like tagged. So like all of the LAN connections that are in marketing, but then there's probably going to be like a VLAN for just printers for marketing. So like marketing printers, and then the marketing actual like devices. What is going on with my hair? Anyway, so that's what I think is the is what it is from when I took CCNA 1, 2, and 3, but that was also a long time ago, and I passed the class, but like it was a crunched course. I think it was a 4-week or 6-week course for each one. It was a lot of information at once.
Basics. Let's get started. So, what is a LAN? In a previous video, I said that a LAN is a group of devices, PCs, servers, routers, switches, etc., in a single location, for example, a home or office. Let's take a look at a more specific definition. A LAN is a single broadcast domain. A broadcast domain is the group of devices which will receive a broadcast frame, that is, a frame with a destination MAC of all Fs, sent by any one of the members. Let's take a look at a diagram. So, take a look at this network here. How many broadcast domains do you think there are? Remember, a broadcast domain includes all devices that will receive a broadcast frame. So, let's say PC1 sends a broadcast frame. And remember that a broadcast frame is a frame with a destination MAC address of all Fs. Which devices will receive the frame? Well,
the only people who will receive the frame will be the switch 1, PC1, and then R1. It won't go all the way, it won't go through, because this is the gatekeeper. This is what connects this grouping. See, I need to get better at vocabulary. This grouping, and this grouping, and this grouping.
This PC1 sends a frame out towards switch 1. And what does a switch do with a broadcast frame? It floods it out all interfaces, except the one it was received on.
Yep.
So the frame is sent to PC2 and R1. What does a router do with a broadcast frame? It doesn't forward it. It will receive the frame, but it won't send it to other networks. So that means this is one broadcast domain, including PC1, PC2, switch 1, and one of R1's interfaces.
So the grouping is called a broadcast domain. Interesting.
So that's one broadcast domain. How many are left? What if PC3 sends a broadcast frame? Which devices will receive it? Switch 2 will receive the frame and flood it out of all interfaces to R1, PC4, and PC5. R1, however, will not forward the broadcast frame. So that's the broadcast domain. PC3, PC4, PC5, switch 2, and one of R1's interfaces. So far, we have found 2 broadcast domains. Now, how about if PC6 sends a broadcast frame? Which devices will receive it? When switch 3 receives it, it will flood the frame to PC7, PC8, and R2 will not forward the frame. So this is the broadcast domain, including PC6, 7, 8, switch 3, and one of R2's interfaces. So we found 3 broadcast domains so far. However, there is one more. What if R1 sends a broadcast frame out of its interface which is connected to R2? It will be received only by R2. However, even though this is a connection between only 2 devices, it is still technically a broadcast domain.
Interesting.
So, do you understand what a broadcast domain is now? A broadcast domain is the group of devices which will receive a broadcast frame with a destination MAC address of all Fs sent by any one of the members. In this network here, there are 4 broadcast domains, and therefore 4 LANs. Here is a small LAN of a company. Let's say there are 3 main departments in this office: engineering, sales, and human resources. Also, the company is using the 192.168.1.0/24 network for this LAN. However, this isn't necessarily the best setup. For both security and performance purposes, it will be best to split up these into separate subnets. For example, let's say a PC in the engineering department sends a broadcast message intended for other PCs in the engineering department. Since it's a broadcast message, the switch will flood it out of all interfaces. So, not only will the PCs in the engineering department receive the broadcast, all PCs, as well as the router, will receive the broadcast. This is a problem for both security and network performance purposes. When it comes to performance, lots of unnecessary broadcast traffic can reduce network performance. Whether it's a broadcast from one end host, or a switch that doesn't know how to reach the destination MAC address so it floods the frame, we should minimize unnecessary traffic in our network. As for security, even within the same office, you want to limit who has access to what. You can apply security policies on a router or firewall. Because this is one LAN, PCs can reach each other directly, without traffic passing through the router. So even if you configure security policies on the router, they won't have any effect. We should separate these hosts so we can apply security policies that determine who can access what in the network. So let's split up these departments into separate subnets. 192.168.1.0/26 for the engineering department, 192.168.1.64/26 for the HR department, and 192.168.1.128/26 for the sales department. However, there's one problem. The router is going to need an IP address in each subnet, so it will need one interface in each subnet. So let's replace this single connection between the switch and router with 3 separate connections, one in each subnet.
Whoa, hold on. That just kind of blew my mind. Because that's exactly what I was sitting there thinking. I was like, man, this subnet isn't going to be able to talk to this subnet, even though they're on the same network. It's going to need to go to a router for the router to reroute it to where it needs to go.
So let's replace this is going to need an IP address in each subnet, so it will need one interface in each subnet. So let's replace this single connection between the switch and router with 3 separate connections, one in each subnet. Actually, there is a more efficient way of doing this. You don't actually have to use 3 separate interfaces, but don't worry about that for now. I will cover that in a future video.
Oh,
so
is that okay? So, because I know that a VLAN goes through, it's virtual, so it just goes through one wire. So is this how that works? That this is all, I guess, tagged, or what's the word? Is it trunked? The trunk? I can't remember. I can't remember what that word means. I'll have to look it up again to refresh my memory. And then it goes here, and then the router just knows. Okay.
You may think the problem is solved now. Let's say this PC in the engineering department has an IP address
so
of
what we're doing right now is we're scaffolding it up. We're just pretending that there's 3 interfaces right here and that they're all on the same network, even though it's in reality it's actually one. We're seeing how it actually breaks down.
168.1.1, and this PC in the sales department has an IP address of 192.168.1.129. If PC1 sends some data to PC2, PC1 will recognize that PC2 is in a different subnet than its own, so it will set the destination MAC address to its default gateway, R1. This is what the frame will look like: source IP of PC1, destination IP of PC2, source MAC of PC1, and destination MAC of R1. PC1 will forward the frame to the switch, which will send it to R1, which will then change the source MAC to its own MAC and the destination MAC to PC2's MAC. It will then forward the frame back to the switch, which will then forward it to the destination, PC2. Okay, so instead of PC1 being able to send traffic directly to PC2, we forced it to send the traffic through R1 first, where we would have configured some security policies and such to control exactly what traffic is allowed to pass between these subnets. However, there is still a problem. Here's the problem. What if the frame is a broadcast or unknown unicast frame? The switch will flood the frame out of all interfaces. For example, here's a broadcast frame. The source IP is PC1's IP, and the destination IP is its subnet's broadcast address. So this is a broadcast frame intended to the engineering department. The source MAC is PC1's, and the destination is the broadcast MAC address of all Fs. Where is the problem? Well, remember that a switch is only aware up to layer 2. It looks at layer 2 information like source and destination MAC addresses only. It doesn't care about layer 3, 4, etc. So, even though there are 3 separate subnets here, the switch doesn't know that. PC1 will send the frame to the switch, it will see the destination MAC address of all Fs and then flood the frame. I'll say it again. This is bad in terms of both network performance and security. So I've shown you that although we separated the 3 departments into 3 subnets, meaning they are separated at layer 3, they are still in the same broadcast domain, the same layer 2 network, or the same LAN. Now, one possible solution is to buy a separate switch for each department. However, that is not very flexible, and network equipment isn't cheap, so buying 1 or more switches for every single department could be too expensive, especially for a small enterprise. However, this is where VLANs come in.
Yeah, see, that's what I thought. Like, each one would need its own switch, and then they would all go to the router. But VLANs are a cheap well, I don't want to say they're always a cheap alternative because they're more than just that, but
although these PCs are all in the same LAN, local area network, we can use VLANs, or virtual local area networks, to separate them at layer 2. We'll assign the engineering department to VLAN 10, the HR department to VLAN 20, and the sales department to VLAN 30. How exactly do we assign these hosts to VLANs? We configure them on the switch. More specifically, on the switch interfaces. You configure the switch interface to be in a specific VLAN, and then the end host connected to that interface is part of that VLAN. The switch will consider each VLAN as a separate LAN and will not forward traffic between VLANs, including broadcast or unknown unicast traffic. So, if we have set up these VLANs, if PC1 sends this broadcast frame, after the frame arrives at the switch, it will be forwarded to all interfaces in the same VLAN. Because the broadcast arrived on an interface configured in VLAN 10, the switch will only forward the frame to other interfaces in VLAN 10. If PC1 wants to send the same unicast frame to PC2, it will function just like before. It sends it to the switch, which sends it to the router, which changes the source and destination MAC addresses, and sends it back to the switch, which sends it to the destination. Notice that the router is used to route between VLANs. The switch does not perform this inter-VLAN routing. It must send the traffic through the router.
yeah. Okay.
Notice that traffic arrives on a VLAN 10 interface and is forwarded out of a VLAN 10 interface. Also, traffic that arrives on the VLAN 30 interface is forwarded out of a VLAN 30 interface, both in the same VLAN. A switch will never forward traffic directly between 2 VLANs like this. Well, first of all, the 2 hosts are in separate subnets, so PC1 itself will send the traffic to its default gateway, R1.
Okay, this actually makes
However,
a lot
even if
more
PC1
sense.
and PC2 were in the same subnet, the switch wouldn't forward the traffic from PC1 to PC2 because they are in separate VLANs. Just a bit of review. VLANs are configured on switches on a per interface basis. VLANs logically separate end hosts at layer 2. Although the hosts in the topology we looked at were physically connected to the same switch, and therefore in the same broadcast domain, we used VLANs to logically separate them and put them in separate broadcast domains.
So can you have multiple VLANs on one interface, or is it one interface per VLAN?
Switches do not forward traffic directly between hosts in different VLANs. As I showed you, the switch must forward the traffic to a router. Actually, there are a couple other methods of inter-VLAN routing, and I will cover them in a future video. Finally, let's take a look at basic VLAN configuration. I've added the interface numbers to the diagram. Interfaces in VLAN 10 are G10 through G13. Interfaces in VLAN 20 are G20 through G22. And interfaces in VLAN 30...
Well, there's no way it can be one VLAN per interface because there's one interface between the switch and the router. Yeah. No, it is not strictly one VLAN per interface. A single physical network surface can handle one or multiple VLANs depending on how you configure it. Okay, so that's the whole point of it being virtualized. Okay. Trunk ports. This is what I was trying to remember. Definition: a trunk port is configured to carry traffic for multiple VLANs simultaneously over one physical cable. Okay. So then this would be the trunk. We're not nowhere near there yet, but
are G30 through G33. Let's go into the CLI and put these interfaces into the proper VLANs. Before configuration, let's look at the VLANs that exist by default on a switch.
Show VLAN
in this output,
brief.
You can see I use the command show VLAN brief. It displays the VLANs that exist on the switch and which interfaces are in each VLAN. Here you can see VLAN 1 with the name default. This is the VLAN that all interfaces are assigned to by default. So even if you don't configure any VLANs, all interfaces are in VLAN 1 by default. Under ports, you can see all of the interfaces on this device, from G00 to G33. Under it are 4 other VLANs, 1002 to 1005, used for FDDI and token ring. These are old technologies that you don't need to know for the CCNA, but feel free to Google them if you're curious. VLANs 1 and 1000 to 1005 exist by default and cannot be deleted. Remember that. This is how you assign
Go back to that. VLANs 1, 1002 to 1005 cannot be deleted. Why? The interface of the IEEE standard common use connecting switch to another switch or connecting a switch to a router, often called route on a stick setup. Oh, because it's one thing. That makes sense. Okay. Why can I not delete VLAN 1, 1002 to 1005? I understand why I can't delete VLAN 1 because they're hard-coded factory default reserved system VLANs baked directly into the network operating system architecture, most notably Cisco iOS. The system requires them to exist to maintain baseline hardware stability and backward compatibility. I understand why you can't delete VLAN 1. That makes sense. It's the default, like whatever, you got to have one. But why can't you delete 1002 to 5? So it's it's this stuff. It's the legacy. So backwards compatible. And that's what these are. Okay. Okay, makes sense.
2005 exists by default and cannot be deleted. Remember that. This is how you assign interfaces to a VLAN. First, I use the interface range command to configure all of the VLAN 10 interfaces at once. Use the switchport mode access command to set the interface as an access port.
Ooh,
What is an access port?
I can't wait to eat
An access port is a switch port which belongs to a single VLAN and usually connects to end hosts like PCs. That's why it's called an access port. It gives the end hosts access to the network. There is another important type of switch port called a trunk port. Switch ports, which carry multiple VLANs, are called trunk ports. I will cover trunk ports in depth in the next video, but for today's video, we will focus only on access ports and take it step by step. A switch port connected to an end host should enter access mode by default.
Sense.
However, it's always a good idea to explicitly configure the setting and not rely on auto-negotiation of port type. Anyway, the last command after switchport mode access is switchport access VLAN 10. This is the command that actually assigns the VLAN to the port. Notice the message that appears after this command. Access VLAN does not exist. Creating VLAN 10. Because VLAN 10 didn't exist on the device yet, it was created automatically when we assigned the interface to VLAN 10. I'll show you how to manually create a VLAN in the next slide. Next, I again use the interface range command to configure all of the VLAN 20 interfaces at once. I use the same switchport mode access command, then switchport access VLAN 20 to assign the interfaces to VLAN 20. Finally, I did the same for VLAN 30, and once again, the VLAN was created automatically. So, I used the show VLAN brief command once again, and here you can see the 3 VLANs we created, and the ports we assigned to each VLAN. Notice the default names of each VLAN. Let's change those to make it more understandable. So, I used the VLAN 10 command to enter configuration mode for VLAN 10. By the way, this is the command to create a VLAN also, but
this command creates a VLAN. In this case, it was already automatically created when it was assigned the interface. So VLAN 10 creates it, then VLAN 10 gets me in there, and then name engineering, VLAN 20, name HR, sales, and so on and so on. That makes sense.
in this case, it was already automatically created when we assigned the interfaces. Next, I assign the name with this simple command, name engineering. Then I do the same for VLAN 20, HR, and VLAN 30, sales. Finally, I confirmed once more with show VLAN brief. Notice that the names have been changed to engineering, HR, and sales. Okay, so that's all for the configurations. If I use the command ping 255.255.255.255 on PC1, which sends a ping with the destination MAC address of all Fs, the broadcast MAC address, the broadcast will only reach hosts in VLAN 10. Likewise, if I use the same command on PC2, the broadcast will only reach PCs in VLAN.
Okay, so this makes sense it being organized, but I can also understand that like if you have one thing misaligned, it can be a huge mess.
30.
So then this would be
The group of devices that will receive a broadcast frame sent by another member in the group. Then I talked about what a VLAN is. It's essentially a way to logically split up a layer 2 broadcast domain to make multiple separate broadcast domains.
Okay, I just was checking this stream. Sorry, I apologize.
We also talked about the purpose of VLANs. The two big reasons are network performance and security. VLANs help to reduce unnecessary broadcast traffic, which helps prevent network congestion and therefore improve network performance. Limiting broadcast and unknown unicast traffic like this also improves network security, since these messages won't be received by devices outside of the VLAN. You should always make sure that network traffic isn't sent unnecessarily to other devices, as much as possible. Finally, we looked at how to configure VLANs on Cisco switches. Specifically, we configured access ports on a Cisco switch and assigned them to a specific VLAN.
Okay, honestly,
There's still plenty to cover
I
about
think
VLANs.
this is way more
but this should
simple
be a
than
good foundation.
the freaking
In Day 17's
subnetting
video,
stuff.
we will cover more topics regarding VLANs. Okay, let's go on to today's quiz. First up, question 1. How many broadcast domains are shown in this network diagram? Pause the video and count.
So this should be 1, 2, 3, 4, 5. There should be 5.
How many broadcast domains you see. Note that no VLANs have been configured, So all hosts are in the same default VLAN, VLAN 1. Pause the video now. Okay, let's check the answer. There are 6 broadcast domains in this network diagram.
Damn it, I forgot this one.
Basically, each router interface and everything connected to it are in one broadcast domain, since no VLANs have been configured. Let's go to question 2. How many broadcast domains are shown in this network diagram? Take note of the configured VLANs.
Okay, so broadcast domains. 1, 2, 3, 4, 5. Should be 5, right? Because of the VLANs?
Pause the video to think about your answer. Okay, let's check. There are 5 broadcast domains here. 1 for each of the configured VLANs, and the connection between the 2 routers is a broadcast domain as well. Let's go to question 3. What happens if you try to assign a switch interface to a VLAN that doesn't exist?
It automatically gets
command
created.
will fail. B, the switch will create the VLAN. C, the interface will be disabled until you create the VLAN.
No.
Or D, all VLANs exist by default.
No.
Pause the video to think about your answer.
B.
Okay, the answer is B. The switch will create the VLAN. As I showed earlier in this video, if you assign a switch interface to a VLAN that doesn't exist yet, the switch will create the VLAN automatically. Let's go to question 4. If PC3 sends a broadcast message, how many devices will receive it? Pause the video to think about your answer.
Okay, if PC3 sends a broadcast message, how many devices will receive it? PC3. The only people who are going to receive the broadcast is going to be this PC, the switch, and then the router.
Okay, let's check the answer. The answer is 3. First of all, the switch will receive it. Then it will send it out of all interfaces in VLAN 20, so the router and the other PC in VLAN 20, making a total of 3 devices. If no VLANs were configured, all other PCs would receive it. But since we have configured VLANs, only these devices in the same VLAN will receive it. Let's go to the final question, question 5. You create VLANs 10, 20, and 30 on a Cisco switch. How many VLANs will be displayed in the output of the show VLAN brief command? A, 3, B, 5, C, 8, or D, 10? Pause the video to think about your answer.
Sorry, I wasn't paying attention. I was thinking about how this all pertains to IPv6 because, like, so far we are 16 days in and we've only talked about IPv4, which apparently is supposed to be getting phased out with IPv. I don't know. Anyway, I was lost in a tangent thought. So you create VLANs 10, 20, and 30 on a Cisco switch. How many VLANs will be displayed in the output of the show VLAN command? So we're going to have 1, 2, 3, 1, 1002, 3, 4, and 5, 8. So it would be 8.
The answer is C, 8.
Yeah.
Let's check it out. As you can see, there are 8 total VLANs.
Because VLAN 1 default you can't get rid of, and then 1001, 2, 3, 2, 3, 4, and 5 are also legacy. You can't delete them. They also can't be deleted.
VLANs 1 and 1002, 3, 4, and 5 exist by default and cannot be deleted. So if you create 3 additional VLANs, there will be a total of 8 VLANs on the switch. Okay, that's all for the quiz. There will be supplementary materials for this video to help you review and practice what you've learned. There will be a flashcard link in the video description, which you can use with the flashcard software Anki to help
the flashcards, man. I gotta do them. They just suck.
Help you review. There will also be a packet tracer practice lab, which you can use to practice the configurations learned in this video.
They suck to do. They don't suck because they're bad. Like, they're really good, and they definitely help. I just hate doing flashcards. That's why I stopped doing them on stream.
That will be in a separate video. Before I wrap up this video, I want to say thank you so much to my JCNP level channel members. Jonathan,
look at these goats.
Mike, Alexander, Van.
From 6 years ago. Okay. We're not ready for the lab. Okay. So here's what we're going to do.
Welcome to Jeremy's IT lab.
We're going to do that packet tracer in a second. And we're not going to watch this whole video from Monday. But we got time. So
welcome to Jeremy's IT lab.
So we're going to review this stuff that blew my mind a little bit. So yeah, it's mainly the practice questions that I want to do. Okay. Nope, I don't want that. Oh, dang it, dude. Windows, why do you suck? I feel like Windows is constantly like pushing me away. It's like they don't want me to use Windows. It's the craziest thing. Okay, anyway. What happened to the music? There we go. So now, if we look at this here, we are going to take this 172.16.0.0/16 network, and we're going to divide it into 4 equal subnets. Okay. Now, for practice, what I'm going to do, I think we might have already done this one. No. Okay, so for practice, what we're going to do is all of it. Like all the steps, all the things to like show that we're competent and that we can do the thing. Okay, so let's see here. 172, 216, 0, 0, and then we have 16. So what we know that we have 16 things. So boom. So our line is right here. That's where we are right now, which means that we have no octet is split. We have 16 bits to deal with. The CIDR is 16. Duh. We know this because that's 8 and 8. So it's 16. So then the mask is going to be 255, 255, 0, 0. The wild card's literally the exact opposite of it. Okay? What we got to do is we have to figure out how we can get this into 4 different subnets. Now, if I remember correctly, this side is subnets. Well, this side of the line is subnet. Okay? It's actually the borrowed. I'll just put this. It's going to get complicated, so I'm going to not do that. And then this side is the addresses. Okay. So what we need to do is figure out how many borrowed bits do we need to move this line over to get 4 subnets, if I'm understanding it correctly. So I believe because the more subnets we have, the less addresses we have, and we don't care about the addresses. So honestly, we should move it to here, right? No, because that's going to do the addresses. Damn it. Tell me the answer.
16.0.0/16 into 4 subnets of equal size. Identify the network and broadcast addresses of the second subnet. So the first step to solving this question is to determine the prefix length we must use. To divide the network into 4 subnets of equal size, we have to borrow 2 bits, because 2 to the power of 2 is 4.
That's what I was missing right there. Okay, so we have 2 to the power of 2. We'll go back to black. 2 to the power of 2 equals 4. Borrowed bits equals the number of subnets. I need to make this worksheet bigger because that like this stuff's just way too small. So the free host is
So
see, this is what was happening to me the other day, is that I was getting confused based on like the words host and subnet and addresses.
when we borrow 2 bits, that makes a /18 prefix length. Change this last bit to 1 and write it in.
There we go. Kind of freeze it up a little bit. So what we did is we moved that line to here, which turned this into 18 because we added 2. And then now we're talking about the... So, okay. So we need to figure out the frozen bits. Well, no, we need to figure out the borrowed bits. So there's actually 3 groups. There's the frozen, there's the borrowed, and then there's the free. Now what trips me up is that we did borrow 2 bits, and I understand why we borrowed 2 bits. Okay? To make it 18. And that's why we multiplied it by 2. Okay, I think I understand. This formula here is, there's 2 of them. It's 2 to the power of the host bits, which will tell us our free addresses. So let's... So we have 1, 2, 3, 8, 9, 10, 11, 12, 13, 14. So we have 14. So 14 to the power of 2. Latest jailbreak on iPad. Don't out me. Okay. Anyway. 2 to the power of 14 is 16,000. 384. And of course, minus 2, 82 is our usable. Okay. This goes for this. But this has the same formula. 2 to the power of 2, which equals 4. Because this tells us our subnets. No, there's no double B. I always do that. What? Why are we not? Okay. This tells us our subnet. This tells us our free address. Yes, that makes sense. And then these are just frozen. Honestly, this worksheet doesn't really do very well with trying to work these examples.
Okay, dotted decimal again. 172.16.64.0. This is the network address of the second subnet. Now, to find the broadcast address, simply change all of the host bits to 1. So, the broadcast address is 172.16.127.255. So,
now, the way he did that is that he either zeroes this stuff out or makes it all flood. So to get the... You put a 1 here. Okay, so to get the network address, like the network, yeah, the network address, you'd put a 1 here. Because we have 1, 0, then we have 1, 0, and then we have 0, 0, and then we have 1, 1. And then that is our 4 addresses. I probably did them in a weird order, but those are our addresses. And then you can do the same thing with this over here. So if I only add up the binary, of this, that would be 255, and then like he did over there, that would be 127. So this is our broadcast. It's starting to make more sense.
So these are the answers to question 4. Finally, question 5. You divide the 172.30.0.0/16 network into subnets of 1,000 hosts each.
Okay. Let's see if we can replicate this. All right, boys. Let's see if we can do it. Yeah, connected recent successful. Here we go. 172 30 0 0 16. So we need 1,000 subnets. So that means, I'll use orange again, I don't care. That means that we need to do 2 to the power of x equals greater than 1,000. So we just need to figure that out. Obviously not 14. So 2 to the power of... Why is this 2 to the power of 10? Why is it not doing it to the power of what? 1,024. That's probably going to be our answer, but let's do 2 to the power of 9. No, it's got to be that. Okay. So 10 is how many bits that we have to borrow. So if we go here, this is what's frozen. Yes. Right? Yes. Frozen. Yes, I'm correct. This is what's frozen. And then we need the borrowed bits. So we need 10 borrowed bits. 8, 9, 10. So that means these are what is borrowed. Okay? So that means if I make them all... Or is it just this one? I think it's just that. No, it's got to be all of them. So then... we make them all ones. Yes, so if we make them all ones, this would be 255. And then 128 plus 64, 8 plus 4 is 12. Carry the 1, that's 3. 3 plus 6 is 9. Drop the 1, so that's 192. So then if we go over here and we do the frozen bits, that's this. Okay. No caret key. So 1, 2, 3, 4, 5, 6 to the power of 6. So that means that we have a possible of 2 to the power of 6. What is 2 to the power of 6? Isn't that 94? 2 to the power of 6. 64. Okay. Obviously, 62 is usable addresses. That's a 6. So 92 is the broadcast. Right? 255, 92.
Need for 1,000 hosts. We will need 10 host bits for 1,000 hosts, because 2 to the power of 10 minus 2 allows for 1,022 hosts. That will leave us with 6 borrowed bits. 6 borrowed bits means we can make 64 subnets. So that's the answer to question 5.
Wait. I did it backwards? How did I do it backwards?
6 borrowed bits. 10 minus 2 allows for 1,022 hosts.
Bro, this just broke my brain again. God, dude, every time I think I understand it.
But to know how many bits we can borrow, we need to find how many host bits we need for 1,000 hosts. We will need 10 host bits for 1,000 hosts, because 2 to the power of 10 minus 2 allows for 1,022 hosts. That will leave us with 6 borrowed bits. Minus 2.
So, host... Okay, no. So, host bits 10.
$1,000 hosts. We will need 10 host bits for 1,000 hosts.
So I got confused because I did this if we needed 1,000 subnets. We didn't need 1,000 subnets. We needed 1,000 hosts. I literally did it completely backwards.
Because 2 to the power of 10 minus 2 allows for 1,022 hosts. That will leave us with 6 borrowed bits. 6 borrowed bits means we can make 64 subnets. So that's the answer to question 5.
Okay, hold on. We're going to do this one correctly. Erase. Okay, let's get rid of all this poo-poo. We don't need that. Okay. So if we go over here, we have our 0. That's green. I don't want it to be green. We have 0. So we need to figure out 1,000 hosts. So we already know this, that it's going to be 2 to the power of 10, which is going to equal, what was it? It was 1,012 or something. 2 to the power of 10. 1,024. So that means that our free addresses, our host bits, is 1,024. And then our usable 4, 5, 6, 7, 8, 9, 10. So our line that we're going to draw is going to be right here. Okay. That makes sense. So that means, if we go back to this nasty orange color, this is our subnet. So that's going to be 2 to 1, 2, 3, 4, 5, 6 to the power of 6. Okay, that's, isn't it 64? 2 to the power of 64. Buddy, I hate when it does that. 2 to the power of 6. 64. I said it wrong. The Google didn't do it wrong. Okay, so that means that we have 64. I don't care about brushes, dude. We have 64 subnets. And in each subnet is 1,200. No, that's our total. Okay. Don't get ahead of myself, okay? Just do this much for right now. The reason, and then how we got 64 is that if we zero this all out and we add just these together, it should equal not 64. How do we get 64?
Okay, let's get to subnetting class A network or subnets. That will leave us with 6 borrowed bits. 6 borrowed bits means we can make 64 subnets. So that's the answer to question 5.
trying to think. I understand why this is 64. So is that why this is 64? But that wouldn't require it to be 1, and everything else would be 0. It's either my NIC is dying or my switch is dying. It's got to be one of the two. Okay. Okay, let's read this real quick.
Right. And the reason it's confusing is that the terminology is genuinely a little sloppy.
I don't
so
care
let's
about that. Read this.
uninventory the givens from H. Find the smallest h, where 2H2 greater than or equal to H. The -2 pays for the network and broadcast slots. Walk the powers of 2 out loud, 256, 512, 1024, until you clear H. Remember, H is a bit count from the right end of the ruler. It is not a prefix and never will be. 3 convert to the new prefix equal to 32. H. This isn't fixing anything, it's reading the same cut from the left end instead of the right. 1 cut, 2 measurements, always summing to 32. 4. Verify the subnet count borrowed bits equal to new prefix, old prefix. Check 2 borrowed greater than or equal to S. If it passes, your prefix satisfies both requirements. If it fails, the 2 demands don't fit in this parent network. The honest answer is not possible. Not a different formula.
This is about fitting things
Audit
into
the budget
the paired network. You need 100 subnets and at least 50 hosts. So P equals 16, S equals 100, H equals 500. Budget is 32 minus 16 equals 16. Okay. You know what? We're gonna do the packet tracer and see if some hands-on stuff is gonna make more sense. I have a feeling that this one's gonna be rough.
Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Also, remember to download this practice lab from the link in the description, and try it out yourself in Packet Tracer. In this lab, we will practice subnetting using VLSM, Variable Length Subnet Masks. This will be very similar to the end of Day 15's lecture video. You will subnet a Class C network into 5 subnets of different sizes. So I highly recommend.
All right, let's do it.
Recommend that you try to complete this lab first, before watching this video to check your answers. We are required to subnet the 192.168.5.0/24 network to provide sufficient addressing for each LAN, as well as the point-to-point connection between R1 and R2. We will follow the same process that I introduced in Day 15's lecture video. Assign the largest subnet at the start of the address space, and then the second largest, etc., until you have assigned each subnet. So that means we will assign subnets in this order: LAN 2, LAN 1, LAN 3, LAN 4, and finally the point-to-point link. The instructions also say to assign the first usable address to the PC in each LAN, and the last usable address to the router. Finally, we should configure static routes so that hosts in each LAN can reach hosts in the other LANs. So let's get started with LAN 2. I hope you've already solved this lab and are just watching this video to check, since I won't go step by step through each calculation like in the lecture video.
Lab is going to
Let me tab out to this document where I've calculated all of the answers. So for LAN 2, we must use a /25 prefix length. LAN 2 only requires 64 hosts, and as I've written below, a /25 prefix length allows for 126. But if we used a /26 prefix length, there would only be enough addresses for 62 hosts.
Here, hold on. So /25, which means we don't have a lot. 126 usable addresses. /26 would be 62 addresses. So that's okay. 25 means that we borrowed 1 bit. We borrowed 1 bit. Okay.
Because we have to subtract 2 for the network and broadcast addresses. So LAN 2's network address is 192.168.5.0, and its broadcast address is 192.168.5.127. Both.
And its broadcast is when we turned everything to zeros, or everything to 1. The network is the 0. But that would mean no, this is the borrowed bit.
/25. Let's assign the addresses to PC2 and R1. Let me go on R1 first. First, enter privileged exec mode with enable, then enter global config mode with configure terminal. R1's gigabit Ethernet 01 interface is in LAN 2, so interface G01 to configure it. The broadcast address is 192.168.5.127, so let's configure R1's IP address as one below it, the last usable address. IP address 192.168.5.126, and for a /25 prefix length, the subnet mask will be 255.255.255.128. Also,
Okay,
let's enable the
okay.
interface with no shutdown. Let's confirm our configuration. Do show IP interface G01. The show IP interface command shows various information about the interface, primarily layer 3 information. You can see here that the IP address has been configured correctly. You may notice the broadcast address of 255.255.255.255. This address basically functions the same as the subnet broadcast address of 192.168.5.127, and it can be used for any network. When we configure other IP addresses and use this show IP interface command, those other interfaces will display the same broadcast address too. Keep in mind, if a host sends a broadcast to 255.255.255.255, it won't be sent to all networks. It will still stay in the local subnet, and a router will not route it to other networks. The subnet broadcast address, however, 192.168.5.127 in this case, can be used by hosts in other subnets to send a broadcast to this subnet. Anyway, I think I'll explain that in a lecture video in the future, so don't worry about it. I just wanted to explain it since you can see it here. Okay, now let's configure PC2. Click on Config, then first set the default gateway to R1, 192.168.5.126. Then click on Fast Ethernet 0, and set the IP address and subnet mask. The first usable address is 192.168.5.1. After you enter it, you can press Tab.
So I think what I need to be able to do is I need to be able to separate any address into subnets. And then I need to be able to find any subnetted address. I need to be able to find its network and find its broadcast. And then I need to be able to have a situation where I need X amount of subnets, X amount of addresses, and then be able to make that happen with a given address, with a given network. I'm starting to kind of see how it's all coming together, of like where my holes in knowledge are.
And notice it tries to fill in the subnet mask for me. However, since this isn't a classful network, it's a subnet, let me change the last octet to 128. Okay, that's all for this subnet. The second largest subnet is LAN 1.
Okay, so it needs 45 hosts. This is our address. So I need 2 to the power of x, which is going to be greater than or equal to 45. So 2 to the power of 5. Not going to make it. So that means it's going to have to be 2 to the power of 6, which is 64. So then what would the slash be? So that means I'm borrowing 6. Now, okay. So the 6 that I just used to make it go 2 to the power of 6, are those the bits that I borrowed? Or is that the amount of bits that I needed for the addresses? So does that mean that it's got to be for the addresses? Give me this. Okay. Actually, no. What am I doing? It'd be so much easier to just do it up here. Where's... Okay. No, don't do that nasty orange. 19192 168 50, and then we have a /24. So, damn it, I did it again. What we did is we took the bits that we needed, which was 6. So 1, 2, 3, 4, 5, 6. Because our interesting octet is the 4th one. And then that means that 2 to the power of 6 equals 64. So 64, 62. But so that means that our address is going to be 192.168.5. Well, wouldn't it just be 0.64? Or do we have to pick up where we last left off?
Let me go back to my document and let's look at LAN 1. So for LAN 1, we'll use a /26.
Yeah, so it would be /26. So this is where it comes into play, where we have to add and subtract the host that we had to the old one.
6 subnet mask. LAN 1 requires 45 hosts, and a /26 subnet mask allows 62.
Yes. Okay, I'm correct. And we have 2 borrowed bits. Which are these right here.
The network address is the next address after LAN 2's broadcast address, so it's 192.168.5.128/26. The broadcast address, with all host bits set to 1, is 192.168.
So all host bits set to 1, that gives us our broadcast. Okay. How do we know what our network address was? How did we get this? How did we get? How do we get 128? Oh, because it's all set to 0, and we put a 1 right there. Because that's 128. So then why did we put a 1 there?
At 5.191. Let's configure the router and the PC. I'll go back to R1 first. Let's configure the G00 interface with the last usable address. Interface G00. IP address 192.168.5.190, 255.255.255.192, which is the subnet mask for /26 prefix length. Enable the interface with no shutdown, and let's check. Do show IP interface G00. The IP address is correct, and you can see the same broadcast address, 255.255.255.255. Next, let's configure PC1. Click on Config, set the gateway to 192.168.5.190, then click on Fast Ethernet 0, set the IP address to 192.168.5.129, hit Tab, and then change the last octet to 192 for the /26 prefix length. That's all for LAN 1. Next up is LAN 3. Let's go back to that document. So for LAN 3, we will use a /28 prefix length, which allows for 14 hosts, exactly the number we need for LAN 3. Keep in mind, in real networking, you want to leave some extra room for future growth, but when taking a test, do exactly as the instructions say. The network address is the next address after LAN 1's broadcast address. So it's 192.168.5.192/28. The broadcast address is 192.168.5.207. Let's go configure R2. Enable conft interface G00. Let's configure the last usable address here. IP address 192.168.5.206, 255.255.255.240, which is the subnet mask for a /28 network. Enable the interface with no shutdown, and let's confirm. Do show IP interface G00. So the IP address is correct. Next, let's configure PC3. Click on Config, set the gateway address to 192.168.5.206. Click on Fast Ethernet 0, IP address of 192.168.5.193. Hit Tab, and then change the last octet here to 240. Okay, that's all for LAN 3. Next is LAN 4. Let's go back to that document. So for LAN 4, we will actually use a /28 also. LAN 4 requires only 9 hosts, so a /29 prefix length, which allows only 6 hosts, would be too small. The network address is 192.168.5.208, and broadcast address is 192.168.5.223. Now let's go back to R2 and configure its G01 interface. Interface G01. IP address 192.168.5.222, 255.255.255.240. Enable the interface with no shutdown. And let's check. Do show IP interface G01. Okay, the IP address looks correct. Let's go to PC4. Config, set the gateway to R2's address, 192.168.5.222. Fast Ethernet 0, set the IP address to the first usable address, 192.168.5.209. Hit Tab, and change the last octet of the subnet mask to 240. That's all for LAN 4. The last subnet we have to assign is the point-to-point connection between R1 and R2. Let's go back to the document. So we can use a /30 or /31. I'm going to go with /30. I just think it's the safe option to go with on a Cisco test. So the network address is 192.168.5.224, and broadcast address is 192.168.5.227. We'll use the first usable address for R1 and last usable address for R2. In fact, those are the only 2 usable addresses. Let's go on R1. Interface G000. IP address 192.168.5.225, 255.255.255.252. Enable the interface with no shutdown. Let's check it. Do show IP interface G000. Okay, the address looks good. Now let's go on R2. Interface G000. IP address 192.168.5.226, 255.255.255.252. And enable it with no shutdown. And finally, let's confirm. Do show IP interface G000. Okay, no problems here. Now the last step is to configure static routes on each router. Each router has 3 connected networks. Those are the point-to-point link, and LAN 1 and LAN 2 for R1, or LAN 3 and LAN 4 for R2. So we'll have to configure 2 static routes for each router. First, let's configure the routes to LAN 1 and LAN 2 here on R2. Exit to go back to global config mode. First, LAN 1. IP route, then LAN 1's network address. 192.168.5.128, 255.255.255.192. Then let me use the question mark here. Note that you can either specify the exit interface of this router or the IP address of the next hop. I'll go with the next hop, 192.168.5.225. Okay, that's it. Next to LAN 2, same thing. IP route 192.168.5.0, 255.255.255.128, and then the next hop of 192.168.5.225. Let's check the...
Okay. I have an idea of what we're going to do next. I'm going to go grab some peanuts. And I like these, but can you make them either be one page only each, or if it has to be 2 pages, make it more evenly spread out? Yeah, I don't like that this little thing is like, why is that there? Just move it up. I'm gonna go grab some peanuts. Okay. Okay, why it deliberates that. So here's my issues, okay? Or here's, I guess, what I need to be able to do. I need to be able to find what network address a subnet is in. Okay? Well, yeah. Yeah, it's fine. Okay. I don't know how did I do that? What is happening? Okay, hold on. I need to be able to subnet, period. Like, understand it. Okay, I need to be able to find what network address a subnet is in. I need to be able to understand the difference between frozen bits, borrowed bits, and host bits when subnetting. What are other things that I'm struggling with? No, my peanuts. Okay. Perfect. I need to be able to find the network address of a subnet. I need to be able to find the of what network address a subnet is in. I need to be able to understand the difference between frozen bits and borrowed bits and host bits when subnetting. I need to be able to be handed a subnetted address and be able to find its network and broadcast addresses. I need to be able to be handed a address that is or is not already subnetted. Well, technically it's, yeah, it's weird. Okay. So I need to be able to handle, to be handed, not handled, handed a address that is or is not already subnetted, and be told that I need X amounts of subnets or hosts and be able to figure it out. I also okay. Snuggling. I'm struggling with subnetting. And finding a network address of a I'm going to give you some worksheets that I have been using to help me learn and some steps and rules that I have created to help me better understand. I will also give you some and I want you to, one, help me make better worksheets. Oh, God bless me. Whew. Help me better make better worksheets for me to practice. If it can be just one page, that is fine, but if it needs to be more, that is okay too. I just don't want it to make like a crap ton of them, and like, because it's not about the quantity of worksheets I have, it's about the quality of it. I really like the, what's it called? But it is hard to see sometimes. Okay. Want it to be bigger and darker. Here are the things that I need to do, that I need to be able to do. Create new. Please help me refine, create new, or no. What are your thoughts? Okay. So we're gonna pump this in Claude. Okay. We're gonna dump those in there. We're gonna dump these in there. God. Okay. Hold on. I'm pretty sure I have a PDF of this. I just don't know where it's at. Let me search my computer real quick. No results. Yep. It was there. Why are you bad? I literally searched subnetting dash worksheet. Came back, said it knew nothing. It's like, no, that file doesn't exist. I searched subnetting, and it's like, oh, are you looking for subnetting dash worksheet? Yes. I would much rather give Claude PDFs than images. Although they're all hard for it to code. All right, now
1,000 hosts. We will need 10 host bits for 1,000 hosts, because 2 to the power...
No, we need to go back one more. He has a really good picture.
range for subnet 4 is 192.168.1.192.
Where's it at? Because he has really good visuals. I think this is going to give him, I think this is going to give Claude shit ton of context of what I want. I do think getting confused with borrowed bits and which ones are borrowed and which ones are not. Okay. Okay, I'm struggling with subnetting and subnetting to subnet and finding the network address of a subnet. I'm going to give you some worksheets that I've been using to help me learn and some step rules that I've created to help me. I will also give you some examples of how I have been learning and how to do things, and I want you to help me All right, go away. Explanations of and done. No. Let's see what it says. I'm excited. Excited to see what it's gonna cook up. By the way, if you're not using AI like this, then you're like absolutely stupid. If you're just using AI to like write papers for you, then you're an idiot. AI is like the #1 world's best teacher. And if you have half a brain, you'll be able to be smart enough to use it in conjunction with other stuff. If you notice, like, I don't ever just use Claude. I'll use Claude, ChatGPT, and Google, and then, like, I'll use Perplexity to, like, research things. Like, thinking that you have a one-stop shop with one thing, not a good idea. And blindly just taking something, even at Google, like, I always have a really hard problem with people saying, like, you can't believe AI 100%. Like, okay, that's always been the case. Like, when I Googled something, did I just believe that one article? No. I kept going. and you look and you research and you start trying to find a consensus. Now, the real trick is when the consensus is wrong. And that's when you have to really use your deductive reasoning skills. So we're gonna kind of let this one we're gonna let this cook for a little bit. I think it's gonna come out really nice. And then we're gonna use it to like study and review for Sunday, because Sunday we're gonna conquer this. Like, I'm tired of thinking I understand it and then like not understanding it. You know what I mean? So, yeah. Because if we go here, we'll let that cook for a second. Subnet. Okay, we're going to use this one. And maybe these videos here might be pretty good too. I don't know. I haven't watched them. We're going to let it cook. So the problem is that this is a good little worksheet, but it's got some flaws in it, right? Okay, we don't need these anymore. Go away. Delete. Okay. So like we can find the one. Dang it. So, buddy. 1, 7, 2, 14, 64, 35, 28. I think another thing that I was getting caught up on is that in my mind, this is subnetted. But in reality, they had all these addresses and they subnetted them into 4 equal parts. Well, equal parts, right? In terms of bits. So if we have /8, that looks like a heart. /8 /16, that looks like 116. /16 /24. And then that looks like 124, 24, and then that would be a /32, right? Because 4 times 8 is 32. These are all the classes, and although we don't really use the classes, it's kind of like the OSI model. Even though we don't use the OSI model anymore, it's still referenced to so much the building blocks of everything else, you know? So I think these are technically subnets, but that's not really what we're thinking about. What I'm thinking about is like, this is the subnet because we cut that bad boy in half, right? So let's check this out. So the bits that are frozen are going to be 8, 16, 24, and then we have 25, 26, 27, 28. Okay? So now this is the interesting octet. Now we need to figure out, or now we have, these are the borrowed bits. These are the frozen bits. And then these are the host bits. So we have 1, 2, 3, 4. So we have dang it, dude. I need to start using my tablet. 2 to the 4th 2 to the 4th, which is 2 times 2 is 4. 4 times 2 is 8. 8 times 8, or 8 times 2 is 16. So that means we have a usable of 14 addresses. That green's a little hard to see, huh? It's a little bit better. Our host bits that we have free is 4. Now, if we go and we talk about this octet here, the octet split is in the 4th, so that means that our frozen bits is 28, CIDR is 28, CIDR 255, 255, 255, and then we have this added up because that's what we just made these all ones, right? So that's gonna be 128 plus 64 plus 32 plus 16. 240. 240. This should have been down here. Okay. So that means our mask value in the octet is 240. Now, I don't understand what it means by mask value. I think that's another thing that I'm getting confused. Like, what is mask value of the octet? Like, what? And I think that's my biggest problem is that I have a bunch of terminology that's getting thrown around. Because then our block size should be our block size should be 240 256 6 1. So our block size is 16. But our number of hosts is 4 to the power of our host, which is 4. Or 2 to the power of it. So that's 16. So that's another way of how to get it, I guess. Maybe not. Numbers can be coincidental. Oh, it's because the octet split directly in half. That's why. It's all going to be like that. So we have 0. We have 0.0. We have 0.16. We have 0.32. So the host of this is 32. One 192.214.64.32. Am I correct? Yeah. Which means that our first host is going to be 192.214.64 16 add, so that's 848. Oh duh. So that means our first one's going to be 33. Our last one's going to be 192 point, no, not 0.0, 0.214.47. No. Yes, that's our last usable host. Why was it 46? Because 48 is the start of the new one. 47 is the broadcast, which means that 46 is the last. So 192.214.24.47. Yes. Okay, let's see what Claude cooked up. Whoa, it's still cooking. Okay, we'll just let it keep going. We'll let it keep cooking. So that is getting easier. I still think that I'm still having issues with understanding what the block value is. Is the block value the same as the borrowed bits? Yeah, it is. Or the mask value. We're still cooking.
Hey YouTube, welcome to the IPv4 Subnet Mastery video series. This video series will be all you need to become a subnetting pro.
No, I don't want to watch that. What I really want is for this to finish. It's deliberating. Okay. I'm supposed to get a haircut today, here in a little bit. Okay, let's ask Google then. What is the mask value when subnetting? The mask value is a 32-bit number used to divide an IP address into two distinct parts: the network portion, which identifies the specific network, and the host portion, which identifies the specific device. For example, the default subnet mask is this. Looks like this in binary, I know that. Mask values can be expressed in two different formats: dotted decimal notation and CIDR notation. The classless inter-domain routing. Writing as a // I know that. Common subnet masks. Values. Oh. So okay, so is the subnet the class, and then the mask is the subnet of the subnet? Number of usable hosts, depending on the size of the network you need. Point to point. Note the number of usable hosts is always calculated by number of bits. So are the class A, B, and C subnets, and then you have the mask, which is like a subnet of a subnet. No, the subnet masks are not a subnet of a subnet. Instead, the subnet mask is a binary line that tells you exactly where the network ends and the host begins. Okay. Historically, networks were divided into rigid fixed groups called classes. Subnets allow you to break those grid classes down into small custom sized pieces. So we had this classes, and then this replaced the classes, I think. We still cooking? Yeah. you want to split the single class C network into two smaller bits, you borrow one bit from the host portion. New custom subnet mask 25. Okay. By changing the mask value, you have dynamically rewritten the rules of the IP space. Instead of one large network at 254 bits or hosts, the router now sees two distinct subnets, each capsulating and holding 126. So they just cut it in half, like in music. Classes were the old rigid default templates in network. Subnets. Okay, so it just so happens like okay. Networks are similar. Custom networks slices. The subnet mask is simply the mathematical tool, the mask that defines how big or small. Okay, so the classes were first, and then subnets came second, and it just so happens with the way subnets work that /8 is class A and /16 is class B, and so on. So does that mean before cider everything was just known as a class A, B, or C? Yes, exactly. You hit the nail on the head. Okay, that makes a lot of sense. Okay, before cider in 1993. Wow, that's crazy. Okay. The problem, the Goldilocks. Okay. The problem, the Goldilocks crisis. The rigid system created massive inefficiencies, and organizations were forced to buy IPs in only 3 fixed sizes: too big, just right for medium; too small, classic. Okay. Because Class C was too small, any decent sized company requested a B block. By the early 90s, the internet faced a massive crisis. The world was completely running out of B class networks, even though millions of individual IP addresses within Class A and within Class A blocks were sitting empty and wasted. Does the Class A, B, and C come That's not how you spell license. What'd I miss? Oh, I forgot the C. We still cooking? Dang, dude. Man. Comparison. Since both systems were used. Okay, cool. I don't care. I just saw a connection. I was interested in it. So, okay. So if subnetting is the fix or the band-aid to make IPv4 work, and it's kind of complicated, then how does that all work with IPv6? Can you subnet a IPv6 address, and why don't companies use private IPv6 addresses to map out their whole network? Because didn't IPv6 fix a lot of these issues? Man, we're still thinking. Dang. Can we read this to me? No, it said screw you, Tyler.
The problem, the Goldilocks crisis. This rigid system created massive inefficiency. Organizations were forced to buy IPs in only 3 fixed sizes.
Will you read it? No.
You have
Oh, dang it.
the problem, the Goldilocks crisis. This rigid system created
Read it. Do it.
You.
Son of a bitch.
You have excellent intuition.
Okay.
You hit on the exact philosophical shift between the two protocols. Yes, IPv6 absolutely fixed the main problems of IPv4. Because it fixed them, it completely changed how we think about subnetting and private addresses. Worldwide technology, or WWT+2. In IPv6, we no longer use band-aids like address conservation, or NAT, network address translation. Internet Society +1. Can you subnet an IPv6 address? Yes, absolutely. However, you subnet IPv6 to organize your network hierarchy, never to conserve addresses. Subnettingpractice.com +1. In IPv4, you do complex math to squeeze exactly 14 hosts into a /28 subnet so you don't waste IPS. In IPv6, the math disappears completely. IPv6 subnetting is built around a single massive rule. Every local network segment, LAN, is permanently a /64 subnet. Server fault +2. A /64 subnet means the first 64 bits are the network, and the last 64 bits are for host devices. A single /64 subnet contains 18 quintillion addresses, 18 times 1018. Whether you have 2 computers or 2 million computers on a VLAN, you still give that VLAN a full /subnettingpractice.com +1. How subnetting actually works in IPv6. An internet service provider, ISP, or registry won't give a company a single IP address. They will hand over a massive block, typically a /48 prefix, capped in DNS +2.
Because the organization gets a /48, every individual LAN must be a /64. The math is beautifully simple. Global routing routing prefix given by ISP is 48 bits. Subnet, your playground, which is 16 bits. And then device.
Because the organization gets a /48, and every individual LAN must be a /64. The math is beautifully simple. Captain DNSSN, set images RC, IMG 9MNFA RO1ELI5 QTSPR NWBU A8 R AM image PNG base.
I don't know what it's reading. Okay, why don't companies use IPv6 addresses to map out their network? IPv6 actually does have private addresses called unique local addresses, ULAs, which start with FD00. They function exactly like IPv4 address private blocks like 10.x.x.x because routers are programmed to never pass them to the public internet. Yet most companies choose not to map their networks to them. Here's why. 1. NAT is now deemed bad engineering. Well, right. Okay. So yet most companies do not map their networks with them. Here's why. 1. NAT is deemed bad engineering, but NAT deals with IPv4. Are we still cooking? Dang. Whoa. This is so much better. Parent network. Frozen, borrowed, find the host bits. Oh my god, dude. Amazing. Amazing. Yes. All been downloaded. Okay, hold on. We're going to read this real quick.
My honest thoughts first. Your system is better than you're giving it credit for. The 32-bit ruler idea in your 6-step method, frozen plus borrowed plus host, must always sum to 32. Plus the audit step and the rule say which section the exponent counts before writing it, are exactly what kills the classic confusion between 2x subnets and 2NA. 2 hosts. The very thing those 2 formula boxes in the Jeremy slide trip people on. And the worksheet layout you like is genuinely good pedagogy. Converting by subtracting down, physically drawing the line, reading the block size. The real gaps were that your kit had no VLSM sheet, no way to see borrowed bits on the dissection sheet,
Right, and that's
and the
what was
design
getting me.
method only ran in the host's first direction. That's what I built around. Each file is 3 pages, blank, filled in worked example, then a step-by-step explanation keyed to circled numbers on the sheet. Subnetting worksheet V2, your favorite layout, kept intact but everything bigger and darker. New, a dashed second line for the parent prefix. So when you're handed a /24 subnetted into /26s, you can literally see frozen or borrowed or host as 3 zones, goals 1 to 4. The example finds which subnet 172.19.20.77 lives in. Subnet design worksheet, your 6-step method as a fillable sheet, with a colored ruler across the top and a branch box for when you're given only subnets instead of hosts, goals 3 and 5. VLSM worksheet, subnetting a subnet, rank biggest first, size each request, place them nose to tail, fit check against the parent, goal 6. Subnetting practice pack, 15 problems with a full answer key. A few are booby-trapped on purpose. A6's address turns out to be a last host. A 7 split is in the 3rd octet, so the 4th never matters. B5 is genuinely impossible. Your method's honest answer rule deserves reps. And C2 makes you VLSM a parent that's already a subnet.
Okay.
The colors match the Jeremy's IT lab slides you're learning from. Blue for network frozen, purple for borrowed, orange for host, so the paper and the videos speak the same language. Print page 1 of each sheet as many times as you need. The problems feed them. If anything's still too small once you print, or you want a second batch of problems, or a time drill version, tell me and I'll adjust. Subnetting worksheet, V2.
We don't need that. Okay. I am so excited about these. I am so excited about these. Like, that looks so good. That looks so good. So are the borrowed bits the same as the mass value in the we'll let that cook. Okay.
NAT is now deemed bad engineering. In IPv4, companies use private addresses out of necessity, forcing them to use a NAT firewall to translate those private IPs into one public IP at the border.
While people think NAT is a security feature, it's actually just an address sharing hack that breaks direct end-to-end communication. It forces routers to keep massive tables of who is talking to what, which degrades the performance and breaks certain types of direct traffic. Like, wow. 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 VoIP, IP, gaming, and secure peer-to-peer connection. So, I don't understand. It said, yet most companies choose not to map their networks with them. And the reason they don't do that is because NAT is deemed as bad engineering. So does IPv6 use NAT? Public IPs.
2. Public IPs are infinite and safe.
No, they're not infinite. See, I think that's a dangerous thing to think. IPv6 has enough addresses, 340 octillion, right? But like, you're assuming that like humans are going to die before we use those up to give every grain of sand on Earth its own IP address.
IPv6 has enough addresses, 340 undecillion, to give every grain of sand on Earth its own public IP address. Because of this, companies use global unicast addresses, GUAs, which are public, globally unique IPs, internally for every single device. YouTube bundle Odom's network upskill 3 plus SM Dursker Centimages RC. IMG9MMF ARO1EL I5QTSPR. Network administrators don't need to hide behind private IPs anymore. Security is handled entirely by stateful firewalls that block incoming traffic, rather than relying on the messy trick of translation.
I don't know, man. I like the idea of it being like locked right here. What you're saying is then that every so a university who decided to do all IPv6 would mean that every single device just goes out. What? No more overlapping IP nightmare when companies merge in the IPv4 world. IT departments face a nightmare. Both companies likely use private range. Initially merge the networks companies' complex, painful readdressing and multi-layered NAT hacks. If a company does choose to use private IPv6, the protocol mandates that they randomly generate a 40-bit ID for their network. So okay, hold on. Did IPv6 fix it? IPv6 removed the stress of conversation. It turned subnetting from a tedious math puzzle into a clean hexadecimal sorting system Would you like to see breaks into hexadecimal segments? So, if a college went to all IPv6 and no longer used IPv4 private addresses, then all of their devices would all get GUAs, which are public addresses and would all reach to the outside world. And then the college would have to put its faith in the what
Close. They're related, but they're not the same thing. And the reason they feel the same comes from the examples you've been practicing on. The mask only marks where the single cut is. Every bit left of the line becomes a 1. Every bit right of it becomes a 0. So the mask's 1 second cover frozen and borrowed together. The mask can't tell them apart. Borrowed bits are just the new 1 second. The ones sitting between the dashed parent line and the solid line on your sheet. Borrowed equal to new prefix, old prefix, while the mask encodes the whole new prefix. Here's why they look identical in practice. When the parent sits exactly on an octet boundary, like /24, the interesting octet starts empty, so every one that lands in it is borrowed. In the worked example, 192.16, 8.10.0, /27 puts 11,100,000 in the 4th octet, and 128 plus 30 borrowed bits. So the mask value and the borrowed bits happen to coincide, and they split apart. Carve a /26 into 28 seconds. Into 28 seconds, the 4th octet of the mask is 11 for 1 second, for 1 second. Yet only 2 are borrowed. The general rule, a mask octet, is the sum of the place values of every one that lands in that octet, no matter which section owns them. The cleanest proof they're different things. 2 networks can wear the exact same mask with different borrowed counts. A 27% cut from a 24 has 3 borrowed bits, 8 subnets. A 27% cut from a 26 has 1 borrowed bits. Same mask either way, 25.255.25. The mask only knows where the solid line is. Counting borrowed bits also requires the dashed line, which is exactly why how many subnet can't be answered from a mask alone without knowing the parent. Where does network end and host begin? How many subnets did I make? DOS.
And that basically says exactly why I always get stuck in that same spot. Yes, you here. I would much rather read it to me. So you're gonna read it?
Yes, you have mapped this out perfectly. If a college switches entirely to IPv6, every single device, from a student's smartphone to a campus server, gets a unique, globally routable global unicast address, go away. Every device can theoretically talk directly to any other device on the global internet without a middleman translating the address. Without private IPs and NAT acting as a barrier, the college has to put its faith in stateful firewalls and zero-trust architecture. Here is exactly how security works in an all IPv6 world, and why it is actually more secure than the old IPv4 way.
Bro, I don't know about that one. I don't know. So what does it mean by stateful firewalls? What are stateful firewalls? Connecting, tracking. Maybe. Okay.
You. Here is exactly how security works in an all IPv6 world, and why it is actually more secure than the old IPv4 way. 1. The core defender, stateful firewalls. In IPv4, people mistakenly believe that NAT provides security because it hides private IP addresses. In reality, security has always come from the firewall, not NAT. In an all IPv6 network, the campus edge router acts as a rigid digital security checkpoint. By default, it runs a stateful firewall configured with a strict rule: allow all outgoing traffic, block all unsolicited incoming traffic. How it works: when a student opens a web browser to go to Google, the firewall opens a temporary state entry tracking that specific request. When Google responds, the firewall checks its table, sees the student asked for it, and lets the data pass through. The block: if a random hacker on the internet tries to connect directly to that student's laptop GUI, the firewall stops it immediately. Even though the laptop has a public address, the firewall refuses to route any traffic to it unless the device inside initiates.
Okay. But how? But if my school-owned laptop is using IPv6 and then that means it is basically connected to the world. So then how would it go through this stateful firewall if there is no reason for it to go through anything at all to reach the outside? Doesn't IPv6 basically kill private networks? You are asking the ultimate question that trips up almost every installation of IPv6. The answer directly no. IPv6 does not allow your laptop to bypass the firewall, even though the laptop is globally unique public address. It is still physically and locally trapped within the school's digital border. Having an IPv6 address means your laptop is accessible by the world, but it is not accessible until the school's network hardware allows it. Here's exactly how your laptop cannot escape the choke point, real world analogy, like your apartment. Here, will you read this to me?
What is the mask value when subnetting? 2. A real-world analogy: the global mailing system. Think of an IP address like a physical home mailing address. IPv4 private addresses are like apartment numbers inside a massive building. A mail carrier from the post office cannot deliver mail directly to apartment 4B. They have to deliver it to the front desk lobby NAT, and the lobby clerk figures out who it belongs to. IPv6 global addresses give every single desk, room, and device their own unique worldwide mailing address. What is the mask value?
No, I'm using this too. I'm also using Jeremy. But I did just make these awesome worksheets that I'm going to use on Sunday. I'm just about gonna wrap up the stream. The stream's just about over. I just went down this really big rabbit hole of IPv6 because I didn't understand it. So I do plan to use these. We just let these cook, and they're really good. I'm super excited to like use these and have them help me with the subnetting. I got practice examples and then answers and why they are the way they are. So we're gonna review that and do that on Sunday. And honestly, I need to get
Nice,
going.
I'm doing day 8 for Jeremy's RN.
Nice, dude. Sweet. Feel free to go check the VODs on my channel. I'm on day 14. Well, actually, I'm technically on day 16. I just was after I finished it, I went back to review because this is what I was struggling with. VLANs honestly make a lot of sense to me, but the subnetting and the being able to be like, hey, we need 500 hosts, and being able to figure it out, that's where I was kind of like losing it a little bit. So feel free to come to the stream 8 a.m. On Sunday. We're gonna be going through these worksheets that we created. Very, very excited for them. And we're just gonna keep using them. This was the original worksheet, and it was working out okay. But there was just a lot of things that it was missing, and I was messing up a lot of things. So yeah, good luck to you, man. Good luck. Really, wish you the best stuff. Thanks for hanging out and coming in and chatting and stuff. So this is my last thing I'm gonna look up. So how does that work with my...
YouTube man, thumbs up.
Hey, thanks, man. So how does that work with my home ISP? Currently, my ISP gives me 2 public IPv4 addresses. So if I switched to IPv6, does that mean my ISP would just give me a block of IPv6 addresses, and then all my devices would be, what is it? Oh, I'm on the wrong one. No, what it's called something. GUAs would be given a GUA. Honestly, none of this really matters right now. I could barely understand IPv4. I don't really need to be doing and figuring things out for IPv6. It's just a rabbit hole that I went down. Yes, exactly. That's precisely how it works. If you have native IPv6 at home, your internet service provider stops handing out individual public IP addresses. Instead, they give your home router a massive block of IPv6 addresses, and your router distributes a unique global unicast address to every device in your house. This process is handled entirely automatically using a feature called prefix delegation. I don't know. How do you say that?
Delegation.
Oh, delegation. Delegation. What the ISP? Fuck, I'm retarded. What is ISP gives you? Instead of giving you a single IP address like blah 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 blah, your ISP delegates a network chunk for the typical residential home ISP, usually out of /60 or out of /56 prefixes. To put the perspective how absurd massive that is compared to your currently 2 IP public IP addresses, your ISP gives you /60, which is 16 separate /64 subnets. Wow. Your ISP gives you /56. That is 256 separate subnets. Those are subnets, not addresses, boys. Remember, a single 60/64 subnet in IPv6 contains 18 quintillion addresses. That's a lot. That's a big number. Your ISP is giving your home address rather enough IP addresses to fuel a small nation. But my thing of it is that if they're giving that to everybody, aren't we just going to end up in the same place that we were last time? How your device gets there. Once your home router receives this block from the ISP, it takes over the local I can't say that word. I know what that word is. I can read that one. Distribution. I did it. It takes one of those available /64 subnets and starts broadcasting to your home using a feature called Slack. Now, I do remember Slack, stateless address auto configuration. Your network shouts to the house, "Hey everyone, our public network prefix for today is blank." Your phone, laptop, smartphone. Okay, I know that said that was going to be our last one, but perks. Okay, here, let's see what the perks are.
The perks of this setup at home. Because every device gets its own GUA, the dynamics of your home network change drastically. No more port forwarding. If you are a gamer or host a home server, you no longer have to log into your router to forward ports. Because your Xbox or PC has its own public GUA, outside traffic can target your device directly, assuming you allow it through the firewall. Server fault +1. The router does less work. In IPv4, your cheap home router has to work incredibly hard keeping track of thousands of open net connections translations for all your devices. In IPv6, the router stops translating. It just acts as a pure, fast highway traffic cop, saving CPU power and lowering network latency. Information Security Stack Exchange +2. Easy guess networks. Because your ISP gives you a whole block, like a /60 with 16 subnets, your router can easily dedicate a completely separate /64 subnet to your guest Wi-Fi and another to your smart home IoT devices. They are totally isolated from each other at the network level without complex IPv4 hacks. 1 uptime +3.
Okay.
Now I see how people get DOSed on COD, LOL.
Yeah, that's what. That's funny. I was actually curious because I hear that IPv6 isn't good for gaming. So, okay, I had a bunch of other questions and then you made me think of that. Okay. But I heard that IPv6 is not good for gaming. Also, what does that mean?
It messes with my Fortnite IPv6. Does it won't communicate the voice chat audio through my Starlink?
It messes with my Fortnite IPv6. Does it won't communicate with my voice chat? Wow. Interesting. So you have Starlink. Okay. Do you like Starlink? I've looked a little bit into it. I've thought about getting it a few times, but I've never done it. What does that mean for companies like ExpressVPN, where they change your IP address but as far as I know, it all operates on IPv4. It's not. Yeah, that's what I thought. Let's see. Oh my god, this stuff doesn't matter at all, but I'm doing it. Okay.
I like Starlink, it's the best thing in my area though. I work at a fiber company and within the next 2 years that will be available to me, so I will switch to that.
Okay. But although it's the only thing that's available to you, like it does okay. Like maybe it's not like the fastest, craziest, whatever internet in the world, but it's like I mean, obviously you're gaming on it and it's doing okay, right? So I would imagine that maybe I don't need a switch, but it is actually okay. The rumors you heard about.
It's really good.
Oh, it's really good. Okay. Well, what's your up and down? What's your download and upload speeds that you like actually get? The rumors you heard about gaming are a bit misunderstood, but your questions about VPN companies like ExpressVPN expose the absolute biggest technical headache of the modern internet. Is IPv6 actually bad for gaming? No, IPv6 is actually superior for gaming. Oh, so says you. But it gets a bad reputation because of lazy implementation. Okay, now that one I believe. No. By ISPs and routers. Why is it better? In theory, online gaming requires rapid, continuous exchanges of tiny data packets between your console/PC and the server. In IPv4, your router has to constantly rip open every packet, translate it, address NAT, and then replace it. IPv6 detects...
Usually 200 for download, I believe it's 40 something for up though.
Okay, so
I
that's...
also have the standard plan though, cause it meets my needs.
Well,
there is the faster 400 Mbps plan though.
I mean...
MBs MB.
That's not necessarily like, I mean, that's not a gig, right? It's not fiber, but honestly, like that's not bad. Like that's gonna, like you could stream with that. Like you could have 4 people watching Netflix at the same time with that. Like that's pretty good. You know what I mean? Why is it better in theory? Online gaming. So IPv6 deletes NAT entirely. Your device talks directly to the game server, which drastically reduces routing, processing, and lag, and completely eliminates matchmaking errors caused by static NAT. So matchmaking errors are caused by static NAT. I wonder how true that is, or modern NAT, which is I think PAT type issues. Why people think it's bad? Because IPv4 has been dominated for 40 years. Internet service providers have optimized their IPv4 routing to perfection. Then ISPs roll out IPv6. They sometimes route the traffic poorly, cause random spikes in ping or rubber banding. Ooh. The rule of thumb, keep IPv6 turned on. It provides a much cleaner, more sustainable connection for modern multiplayer games, especially the Xbox and PlayStation architecture. But that would mean I would have to turn my entire house into IPv6, right? Only toggle it off if specified ISP routing is causing stability issues. How do VPN...
It is true that IPv6 is good. I only have problems with Fortnite, specifically with IPv6.
Interesting. That's very interesting to me. You are entirely correct. Most of the entire global commercial VPN industry was built from the ground up to operate IPv4 infrastructure. This mismatch creates a massive security flaw known as an IPv6 leak. Imagine you're using ExpressVPN. Your computer wants to talk to a website. 1. The IPv4 route ExpressVPN creates a secure encrypted tunnel. It takes all your IPv4 requests, hides your real IP, and gives you a fake one. The IPv6 blind spot. If the website you visit supports IPv6, your computer might try to bypass the VPN and send data directly to your ISP, faster IPv6 connection. Oh. because many VPN protocols do not know how to encrypt IPv6, that data slips through. So it's not that they can't, it's that they don't know
That
how.
might not be good for certain websites, lol.
Yeah, it might not be. Wink. The IPv blind spot. Wait, because many VPN protocols do not know how to. So it's not that they can't, it's that they just don't know how. Don't know how to encrypt IPv4 traffic. That data slips through the secure tunnel. The website instantly sees your true unencrypted residential IPv6 GUA, meaning your location and identity are exposed despite having a VPN turned on. So if you're doing some things that you want to be anonymous for, turning off your IPv6 would be the best. How ExpressVPN fixes this, the secret hack. Because building a global network of native IPv6 VPN servers is incredibly expensive and complex, commercial VPNs use a clever trick to protect you. Instead of routing your IPv6 traffic, ExpressVPN forcefully blocks or disables IPv6 at the software level the second you hit connect. So the moment wow, what would that do if I had my entire house connected to IPv6 and I shut off all IPv4 and then I tried to connect to ExpressVPN? Would it then not be able to do it? Or what if I had it both running? I guess if I had both of it running, it would just shut off all of the IPv6. Interesting. Instead of routing the IPv6 traffic, ExpressVPN forcibly blocks or disables all of it at a software level. ExpressVPN utilizes a feature in its app called IPv6 leak prevention. When activated, the software tracks your operating system, Windows, Mac, etc., tricks it into believing your network doesn't support IPv6 at all. Your device is forced to drop down to IPv4 only mode, forcing 100% of your internet traffic. Wow, I had no idea. That's so interesting. While the internet
IPv6 should work for the other devices that aren't connected to the VPN. But the IPv4 not being connected to the main device probably means it won't connect.
Yeah, that's what I'm thinking. That's exactly what I'm thinking. You are trying to secure your home network with a VPN, or are you hoping to find a VPN provider that offers true native IPv6 routing without forcing you back? Wow. Well, I mean, okay, this will be the last one for sure. Okay. Are there any VPN companies that native IPv6 routing? Dude, the internet's so crazy. Yes, there are a handful. Hide Me, Proton. I've heard of Proton before. Wow. That's... Oh my god, dude, that's crazy. Okay. All right. Enough going down the rabbit hole. I got to take care of some things before I go get my hair cut and then have to go immediately to work. So, thanks for hanging out. Thanks for chilling. On Sunday, we are going to hit it hard with these worksheets that we made right here. And then,
probably makes bank, LOL. See you later, dude.
Later. Makes bank. Yeah, I bet it does. Later, man. Thanks for hanging out. Sunday, 8 a.m., we're going to do a review session. If you haven't already, please subscribe to Jeremy's Tech Lab, IT Lab, and then also subscribe to my channel as well. I got some videos there. As soon as I feel strong enough with subnetting and all these things, I'm going to make a very detailed video that breaks it all down. I'm going to try to make it as simple as possible, and I'm going to give out these worksheets for free. Okay, so that way people can use them as well. And that way you can understand things and whatnot. So that's what's going on. I hope you enjoyed it. I hope you learned stuff. Remember, work with what you got, build what you need, and I will catch you in the next one. Later.